experiment is acid-base titration. So a base is recognized as what? Is accepting all the protons from an acid. An acid is donating all the protons to the base. Now, if I have two bottles, one is acid, one is base, how can recognize them? Both of them, they have no odor, no smell. But how can I tell this is an acid or base? Somebody will help me? I need help. So how you tell?
Litmus paper.
Litmus paper, that's good. Suppose I don't have litmus paper, and I have something at household, Drano, sodium hydroxide, and I have vinegar. So how the labels are out? So how do I know that's the Drano? How the acetic acid? Acetic does smell, correct? But what's the acid is stinging, and the base is soapy. Soapy means slippery. Any compound that's slippery, it has to be basic. So any slippery compounds, not the oil. The oils have nothing to do with this, but soapy inorganic compounds, they turn out to be basic, correct? And stingy stuff has to be what? An acid. That's a general thing. Litmus paper would be nice, but we don't have a litmus paper at home, so but you can differentiate between them. So today we'll have to titrate. Sodium hydroxide will be my known concentration. Is there on the bottle said 0.1302 molar, 0.1302 molar. I know the concentration of this, but I don't know the concentration of the vinegar. Here it is. I don't know the concentration of vinegar. So titration is a method is used to determine the concentration of unknown acid or base. I can reverse this one. I can put the acid here, acetic acid, known molarity, and I put sodium hydroxide's unknown molarity, correct? I can switch their position. So determination of unknown concentration of an acid or a base. Whatever you like the unknown might be, but today it's unknown our the acid, acetic acid, found in vinegar, and the theoretical value is 5%. From the FDA, on the bottle it said 5%, correct? And today we'll know our percentage error. How close are we? We are from the 5% of the theoretical value approved by the FDA, 5%, correct? So the first thing here I have to clean up my, I call what conditioning my burette. The burette has a lot of impurities, and they know what's inside. So the better is to condition it with the same sodium hydroxide I will be using. So the inner walls of the burette will be covered with the fresh sodium hydroxide, maybe a couple milliliters, not that much. Then I will have my waste. If you look at this, here it is, guys. This is my waste beaker here all the time. Did I put it? I used this one here, correct? So let me see. So I'll condition it now. Trying to rotate the whole thing here. Look at this. Conditioning with sodium hydroxide. So sodium hydroxide is conditioning the inner wall of the burette. So everything is covered by sodium hydroxide. Now I want to make sure that I did not mix the acid or base. I did not clean it with an acid. So I put 3 drops of phenolphthalein. Phenolphthalein will turn pink in sodium hydroxide, will turn colorless in acetic acid. So it has to show now what? Pink. If I clean it, yes, I wash it. That's really true. I did wash it with what? Sodium hydroxide. That's the proof here. That's sodium hydroxide, correct? So I did wash it with sodium hydroxide. Now I let the stop cook. Now open here. So this is going through here, and number 1 is my sodium hydroxide. Looks like it's stuck, but with the pressure of sodium hydroxide, it will go through. Yes, it's now you see, it's going through, correct? So close it, and now time to put it in. Very closely here with feelings, not let this go and break the burette. It's a very expensive glassware, and it's the best calibrated glassware. So the best calibrated glassware we know is burettes. correct? So burette is followed by volumetric flask, followed by pipettes, and then graduate cylinder, and the beaker is the worst glassware because it's not really very fine calibration, correct? Very crude calibration. So now it's conditioned. I will add to this here. Now you can see this very hard to me. I might spill on myself. So it's better here to have a small tiny stool. Maybe a small tiny flat stool here. One of the stools here, small flat one. Small one. Not the large one, the big one, the small one. Small stool. Because I want to see the level. So the burette has dead volume above 0. That's a 0 here. Above 0, I don't know. It's not calibrated. And the dead volume here, below 50. Dead volume means it's not calibrated. It's calibrated between 0 and 50. If it goes beyond 0, beyond 50, so I have no use for this data. So I don't know. It's not calibrated. If it started with above 0, this data cannot be used because I don't know what above 0 is. So my data has to be between 0 and 50. Above 0 is dead volume, it's not calibrated, and below 50 is not calibrated. So now, to avoid any accidents, I'll take the whole thing here and put it under tiny stool so I have more control on it, correct? Now I have to make sure this one is what? Closed. And put my waste beaker at the bottom. So to make sure that I have no accident and the stopcock has no problem, no leaking. And if it leaks, it will leak to what? To the beaker. If there is an accident, just let me know because it's soapy and very slippery. Sodium hydroxide on the floor is very dangerous because it's like a soap. It's very soapy, so it's very dangerous. So just let me know. So I'll put my sodium hydroxide here. I'll try to put it what? So let me see here. That's a vinegar. You can smell it, correct? You can smell it. So I put this one all the way to 0. Now it might go above 0, but I will just adjust it to have to be on 0. So now it looks like it is above 0, so I have to lean myself up so my eyes perpendicular on the meniscus inside the burette. It has to be 90 degrees perpendicular to the meniscus. You see the meniscus here at the top? It's a little bit curved. So I have to have it above the 0, not on 0, but above the 0. So the meniscus is here, and I'm looking at this. So I have to lean myself down here and see where is my 0 here. So I can't see it very well. So in this case, I need a tissue. So bring me a tissue here, a brown tissue. Bring me a brown tissue here. Yes. Do you have a brown one? Brown one will be much better than the white one. But anyway, so in this case, I do it like this way here. You can see it now. You see the 0, mine 0. Where is my 0? Can you see it here? My 0 is, look at my 0 is. My 0 is here, and I'm above the 0, correct? So now I drain a little bit until I get to I'm draining it slowly. Now it's above 0, exactly perpendicular on the 0 itself. So I use this one here too. So now this one is ready to go for titration. So that's my waste. I keep it all the time, and then at the end I dump it inside the sink and rinse it with tap water. So this is up. Time to go here up, so I can titrate now. Save. Take my funnel aside. In this flask here, that's Elmeyer flask. I call it titrating flask here. All the titration process will come into this here. So what we have to add? We have to add 10 mL of distilled H2O, 10 mL. You can add 20 mL, it doesn't really matter. So I use H2O to help me to see the end point. The end point will come from acetic acid colorless, correct, to what? To a pink color. I'm using an indicator for this. The indicator is called phenolphthalein. So, regardless of whatever you use H2O, suppose somebody will use 100 mL. Does it affect the molarity? No, because we are calculating number of moles. We are calculating what? Number of moles. So number of moles does not is affected by H2O that I am adding. The H2O I am adding just to help me visualize the pink color from non-color to pink, so I can see it much better. So I need somebody who will be volunteering with 10 distilled H2O. Use the bottle here. Yeah. Here, this one? Okay, that's good. Let's add 10 mL. Now suppose I added by mistake 15. That's fine. So 10 mL. That's about 10 mL, yeah, 1 drop maybe. Yeah. So if I added 15 or 20, it does not really matter. Because I'm calculating what number of moles. I'm calculating number of moles. The H2O here is added to just visualize, to help me visualize the pink color. So here it is. This is my H2O. I need the indicator. Indicators are organic compounds that helps us to visualize the acidic medium from basic medium. I can tell with the help of this if I have an acid or a base. Now today if I have an acid, it will be colorless. If I have a base, it will be what? Pink. And this is similar to the organic dye you put it in your hair, correct? Organic dye you put it in hair. If you have an acid, you get a color. If you get an acid, you get the organic dye will another color, correct? Organic dyes are really is indicators in general. So they are changing their color according to the medium they are in, whether acidic or basic. So I'll put how many? 3 drops. So 1, 2, 3. So this 3 drops, and now I have to pipette the vinegar here, which is, I think that's a vinegar here. Waft a little bit, just to make sure that you don't mix the sodium hydroxide with the vinegar. It's really vinegar, you can smell, verify it. So now I have to pipette 2 mL. The 2 mL is, the line of the 2 mL is here, correct? And this is called the pipette adapter, and it has a wheel going up, created a vacuum which is sucking the whole thing up. When you want to release the whole thing, just you can go with the wheel down, so that will bring the whole thing. Now, sometimes if the adapter is not working, there will be some hole inside those the adapter mouth, which is a plastic here. It is. If it's not working, then it has a leak here. So there is not vacuum created. So we'll hope it will work very well. So if it's not, then we'll replace it. So now with feelings, I don't have to push it, but just like this. You don't have to push it very hard, just sitting like this, correct? And I'm trying to get 2 mL up to what line? To this line here, to this line. Can you see it? Yeah, it's 1.2, 1.0. This is, yeah, 2.0 is here. It's here. Let me see where's the line. It has too many lines. If you can visualize the lines there. So it has too many lines, correct? So it has a number on each line. That's 1.3, and then it goes up, and this is 2.0. Here it is, the last one. So let's immerse this one here, not all the way touching the whole thing. We'll turn out the wheel here, up. See here? A little bit up, 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 up. And then just let the wheel here. We have what? Can I take it and blow with my mouth? Can I blow my mouth the rest? No, that's part of the error, correct? So no blowing in the mouth. So just leave it there. Now we have how many components? We have 3 components here. We have 3 drops of the indicator, colorless. See here, no color. If it's a base, it will give me pink, so no color. And then I have 2 mL of acetic acid, and then 10 mL of H2O. Now, if you get more than 10 mL H2O, it does not really matter, just for the color. Now I'll start generously here. I'll start here, take the whole thing up, and I have to really everything down. So I'll start. I don't know where the end point is. The end point when the color change from colorless to what? To pink. And this pink stays at least for 15 seconds. It's not appearing, correct? So now let's see here. I will add generously here 1 ml at the time, but at the same time I need the tissue to see the color very well. I need the tissue. So if somebody will give me the tissue, a tissue please. Yeah, I would like to see brown tissue so you can see. Okay. So here tissue here underneath. Why? Because I need to see the color very well. So here's the tissue, and let's add this one here a little bit generously. With that, that's the beginning here. See here, I'm adding, and then keep what? Keep an eye in the color. The color will start coming pink, on and off, on and off, on and off. When it comes to the end point, the pink will remain more time, but it disappears. Then that means we are very close to the end point, correct? With the end point. So that's we are determining the end point by color change. So I'm adding more, and you'll see the color will persist after a while. Adding more, adding more, adding more. See here the color? Adding more. Now start the pink color. So now I'll add just dropwise. Okay, here it is. 1 drop at a time. See here? And then see here, 1 drop at a time here, guys. See it? And when it starts, the pink color will remain. So I stop. That's my end point. Just keep adding. This takes time, time consuming. The first trial is consuming because I don't know where the end point. The second one is easy. I'll let it run to very close to the value, correct? So here it is. Okay, so here it is. Yeah, that's a little bit, 1 drop off a little bit, correct? 1 drop maybe I added more, but it is light pink, but it can be lighter if I go 1 drop out. So it's not bad. So I come here and then look at the bottom of the value here and record the value. So I'll take a little bit up here. It says 17.3. I'll take 17.25. 17.25. Correct? 17.25. Can you see it? Can you see it, guys? 17.25. This is my titration value, which I have to use it to calculate the number of moles and then calculate the molarity of acetic acid. Everybody's following? Everybody's following? Now, any question you have? If I keep this color here, this color will disappear. What happened? This color here tells me 1 drop of sodium hydroxide turned the acetic acid with the phenolphthalein from colorless to pink. 1 drop sodium hydroxide turned it pink, which is here, correct? See how nice the color is? Now, if I will keep it here for a couple hours, this colorless will turn to pink. What's happened? The pink color will turn colorless. Or if I have exhaled, the color will disappear. What's happened? If I keep it for a while, the color pink will disappear, correct? I'm exhaling what? CO2. CO2 and H2O makes what? Carbonic acid. I'm adding an acid to this. See, the color is out. Do we need some voodoo stuff? Chicken bones. And the blood of the chicken. Oh, look at that. That's a real voodoo, correct? The color is gone. What's happening? It was basic by 1 drop of sodium hydroxide. But I added an acid to it, carbonic acid from my mouth, CO2 plus H2O. That's in your soda, correct? The fuzzing gas, that's carbonic acid, CO2 gas dissolved in H2O. Now it's back, correct? If I need it to be blue back, let's do chicken bone stuff. A voodoo, then add 1 drop of sodium hydroxide. Here it is. Wow. Can I reverse the color? Yes. I have to what? Carbon dioxide from the air or exhale CO2 inside. The pink color will turn off. So, everybody is following now? So, we did very well. Now let's do some calculations. Let's go on the board. Let's do some calculations. Okay? So that's the titration here. We'll do two titrations, 2 trials, correct? So let's go for the calculations here. Let's do the calculations here. So, okay, so. Okay, guys.
Are we supposed to keep recording?
What's that?
Are we supposed to keep recording?
Yes, keep recording. Well, you can hold it and then just hold it and I'll bring some papers. Hold it, I'll put some papers. Hold it for this. This is enough now. Then they will record the whole thing again. I'll bring some papers.